basically, we're talking about a coach. He's got some students here, and he or she has some students, I should say, and they're basically shouting out directions, like commands, right? So basically, there are three different commands that the coach can say. It's L, R, or A. If it's L, you want to turn left. If it's R, you want to turn right. If it's A, you want to turn 180 degrees. That's basically the idea. But some of these students, and specifically at least one, but not all of these students, consistently mixes up left and right. So basically, every time they hear left, they'll turn right. Every time they hear right, they'll turn left. So it's totally consistent. It's not like they're just going in a random direction each time. It's consistent. They're just wrong. At least some of them. Okay, so why is that? Well, basically what it shows in the illustration here is that one of them is always going to be facing the wrong way at essentially every in-between step, right? So basically, if they're all facing forward or all facing backward, they're not going to have any mix-ups. But if they're supposed to be facing left or facing right, they invariably will have mix-ups, okay? So they will not all be facing in the right direction, or in the correct direction, I should say. Not necessarily right. Anyway, point is, specifically, some of them are going to be going in the wrong direction. Okay, not all of them, but some of them. Basically, the idea behind this is we want to tell when they're all going to be lined up the same way. And the reason we need for some of them and not all of them to be going in the wrong direction each time is so that basically when they're in these kinds of orientations, not all of them will be facing in the same direction. You know, if it happened to be that all of them were going in the wrong direction, then, you know, it says turn left and they all turn right. Well, now they're facing all in the same direction. So we don't want that. So that's why it has to be at least one of them, but not all of them that are going in the wrong direction. Okay, cool. So the way we want to start this is basically by doing sort of like a student object, an object for one of these dudes here. And they'll have a direction, maybe they'll have some other attributes, and then we'll have a larger object that's going to be sort of like the whole lineup of them. That's going to be the idea. And then we'll sort of shout out commands and stuff like that. But one way to think about this is kind of like, if you remember when we're doing objects like linked lists and things like that, how we would come up with an object for a node, and then we'd come up for an object for the list itself, which basically links together a bunch of those nodes. So this is going to be sort of similar in some ways, in the sense that we're going to have a student object, and yeah, we'll maybe give the constructor an argument in just a little bit, but before we do, we want to build this up a little bit. So basically, the way we were looking at this before is we sort of had this like direction thing, right? So for our directions, I think we had something like this. Directions. What directions could we have here? Well, basically, they could be facing forward, they could be facing left, they could be facing backward, or they could be facing right. Okay? And basically, the way we can navigate this thing is we could say something like let direction index. I'll just say dir index here, just for short, because we don't want it too big. So we could start this out at 0, and then basically a left turn would look like, oh, that's new, isn't it? Oh, okay. I thought I hit an enter and I didn't get a comment on the next line. But anyway, left turn. So basically what we want to do for a left turn is we would say direction index is assigned the value of direction index plus 1 mod 4. Okay, so for this one, direction index plus 1, so we're adding 1 to the direction index. So it starts out as 0, we add 1, and then it would be 1. So directions at 1 would be L. Okay, so we started as forward, we turn left, now we're facing left. If we turn left again, now we're facing backwards, turn left again, now we're facing right. Turn left one more time, and we're going to be facing forward. So that's why the mod 4, because we want this to sort of repeat. And yeah, so Rainbow, which tasks use the linked list? I'll get back to you on that one, but I know, for example, there was some in the core where we used sort of like a modified version of a linked list. I don't know if it was circle of numbers. Yeah, so circle of numbers would be one of them. So that was task 6. And then phone call, we did, so task 8 in the core, phone call, we did kind of a modified version of it where it was like a linked list that eventually loops around on itself, kind of like a fish hook or a candy cane. Anyway, point is, for now, it's not quite a linked list that we're going to be looking at. It's just sort of, there's some similarities in terms of the structure. Anyway, going back to this whole direction index thing here, basically if we wanted to do a right turn, then we would just say direction index is assigned the value of direction index minus 1 mod 4. But here's the thing. So if we were facing backwards, you want to turn right, now you're facing left, turn right again, now you're facing forward, you want to turn right again. What's going to happen here, though, I think we're going to have to be careful because if we were already at 0 for the direction index and we de-incremented it one more time, I think we would be at -1. Let's just find out, I guess. We might as well. So if we were at -1 and we try to do a mod 4, what is that going to give us? Is it going to give us -1? Is it going to give us 3? What kind of a number can we expect? Yeah, -1. So we don't want -1 because that's not an index here. That wouldn't work. So instead, yeah, we're going to subtract 1, but we're also going to add 4 just so that we don't get into the negatives. But if you think about it, I guess we could just add 3 and it would be the same thing, right? I mean, subtract 1, add 4, isn't that the same thing? So add 3, mod 4. Well, let's see. If we were facing, what direction do we want to face? I guess forward, okay? So this is a direction index of 0. We increase that by 3, and now 3 mod 4 is still 3. So it would be 3. Well, that is R. So we would be facing right. Well, let's try that again. So the direction index is 3. We're going to add 3 to that again, and then mod 4. So 3 plus 3 would be 6. Mod 4 would get 2. Well, yeah, that is giving us the right index because that would mean we're facing backward at this point. So we've done 2 right turns, we'd be facing backwards. Well, actually, that brings us to our next point. So turning around. Oh, that's why it's A. A for around. Okay, makes sense. Direction index would be assigned the value of whatever it was plus 2 mod 4. That's basically the idea. So, if you're facing forward, you turn around, then you're facing backwards. If you're facing left and you turn around, now you're facing right. Okay, so, and again, like we've got the mod 4, so that if you're facing right, it would increment 2, but it would loop around and you'd end up at left. All right, so basically that's how all that can work. But the thing is, what are we even using this for? Like we'd say direction starts out as forward, and then we could say that maybe each of the students has a direction index, and that starts out as 0, and then we would have, all these kinds of things. So, in fact, we could do something like this. This.turn is assigned the value of a function, which takes in, what should I call this? Maybe command? Yeah, I think command works, because it's basically going to be A, L, or R. And then basically we'll say, okay, let's call this turn factor. It's kind of a fancy name for this, but basically turn factor is going to be, I think we used an object for this last time actually. So it was right, left, or around. And basically right would mean that we're increasing by 3, left we increase by 1, around we increase by 2. So that's sort of the idea there. And then what are we going to have in here? Basically command. Okay, so we're saying turn factor is, okay, this is like a legend. It's like a key, right? Well, okay, maybe that's confusing because technically these are keys, these are values. Anyway, point is, this is like a legend. So we're taking our command. The command starts as a number. And then we basically want to turn it into, it starts as a letter. Yeah, those things are called letters. Anyway, it starts as a letter and we want to turn it into a number. That's the idea. So we want R to turn into 3 so that, because we found with a right turn, we were increasing by 3. We want L to turn into 1 because we found with a left turn, we were increasing by 1. So you can probably get an idea of what we want to do with these numbers here. But the main thing is that we're sort of using this almost as like a switch, if you're familiar with the concept. So that's a nice thing about JavaScript objects. We can easily use them that way. And, we could technically give this a name, like we could call it legend or something like that and say legend.command. But I think, for now, this is probably, actually, you know what? Maybe we'll do that because I don't want to be repeating myself if I don't have to. So I'll just put it at the very top. Const legend is assigned the value of that thing. Okay, cool. And then, yeah, basically what we find over here is just we grab it from the legend. This is converting the letter to a number, and specifically the number is how many times we need to turn around. So we'll say this dot direction index is going to be assigned the value of whatever it was, plus whatever the turn factor is, and then mod 4. And there we go. Okay, so basically this is a nice generic turn function. I say generic in the sense that we don't need like a turn left, a turn right, and a turn around function. Like we could have made 3 separate functions for each of these, but it's a little more efficient to do it this way because then we can just feed in the command and this will sort it out however we need to. I should probably mention there's another way to do this legend thing. We sort of looked at it briefly last time, but maybe we'll bring it back a little later. The main thing is, okay, let's build up a little more just so we can sort of see how this is all fitting together. And then we'll talk about where we're going to go from there. Yeah, does that make sense? Ooh. Okay. I think there is something we're going to have to change in a little bit, but before we get there, let's just build up a little more of this stuff. So this is kind of the parallel I wanted to draw to the linked list in the sense that normally we'd have like a class for a node and then a separate class for the linked list itself so that we can sort of manipulate the linked list as its own object. It would have its own methods and properties. And one of those properties would be something like an array. Well, okay, in a linked list, it wouldn't be an array because that would defeat the purpose. But in this case, we're going to have an array of students. Okay, so we're going to have some group of students within our line object here. So specifically, we could say something like this dot students is assign the value of just this empty array, right? It's going to start out, it has nothing in it. And in fact, here, let's give it an argument. So we'll say length, and this will be how long we want the students array to be. Okay, so we'll do something like this. We'll say while length, and we're basically just going to load it up. Okay, so we'll say const student. This is going to be a new student, so a new one of these objects here, and maybe we'll try to get all of that on screen at once. Oh, that's nice. Okay, so this is going to be a new student, and anything else? Anything else we need here? I guess just for now, we'll do a this.students.push student. Okay, cool. And then we'll do a length minus because we push a student in there. All right, cool. So we'll get this lineup of students. What do we want to do next here? Well, okay. So first, we'll do a couple of functions here. So we want to do, we'll say this.coach, or here, we'll say this.shout. Let's try that. This.shout is going to be a function which takes in a command. And the idea is that we're basically just going to feed in one command at a time to this shout function. Okay, it's the coach shouting out the letters. That's basically the idea. And what do we want to do with this? Well, basically this.students.for each, and then we're just going to do for each of these students, we'll do student.turn with an input of the command that we have right here. What's student.turn? Oh, great question. It's this, okay? It's the thing that we came up with over here. So keep in mind each of these student things here, it's part of the this.students array, which we're loading up with a bunch of these student objects. So each of those objects is gonna have this turn method. Keep in mind the turn method takes in one argument, which represents the command. It'll be either A, L, or R. We're going to use that to determine how much they're going to turn, what the turn factor is, according to our legend up here. And we're calling this turn function for every one of the students inside the this.students array in our line object. Okay, so that's basically the idea. And then what do we want to do from there? Well, I guess at this point, we sort of want to check at the end of it, did they end up in the right, did they all end up being in the same direction? That's sort of the idea. Okay, so we'll say const direction is assign the value of this dot students at 0 dot direction. I guess we'll go with direction. We technically have direction and direction index, but let's go with direction for now. And what we want to return at the end of this shout function is basically a true or false value. True if they all ended up in the same orientation, like over here. False if they ended up in different orientations, like over here, if they're not all facing the same direction. So we could go through like a whole loop, a whole way of doing that. We could probably get like student.turn to return something to say like what direction they're facing in. But I think the way we're going to do this is we'll just do this dot students dot every. So this is a nice little built-in for arrays. It's kind of like a way of saying, like we could do the same thing with like a filter or something like that. But basically the idea is that we want to check if every single one of these students is going to return the same thing for the function we're about to put into the everything here. Let's maybe make that more clear by actually putting something in here. So what we want to say is that the student.direction is equal to direction. Okay, and when I say direction, let's just get a bit more space in here. I'm talking about this up here, okay, the current direction that the students are facing in, or at least, well, okay, the way we're saying it is we're saying, okay, well, if they're all facing the same direction, we're gonna just take the first one, and they should all be facing in the same direction as that first one. So we'll take the first one's direction, or the 0th one technically, and we'll see, do all of them have that same property? And in this case, we'd say, okay, so the first guy here is facing left. Are they all facing left? No, they're not. So every would return false, as opposed to up here, every would return true. And yeah, Rainbow, I agree with you, man. Dot sum is also a really nice one. We could do the same thing over here, right? We could say something like this and make it sort of a double negative. Return not this dot sum. This dot students dot sum facing in the wrong direction. Okay, so basically we're saying none of them are facing in the wrong direction, which is equivalent to saying they're all facing in the right direction, or in the correct direction. That's what I mean. Okay, cool. So a couple things I want to say about this. So yeah, this is going to tell us if we're all facing in the same direction. But the thing is, take a look at this. This is actually broken right now because in terms of what our direction is, we assign it the value f, and then it never changes. Like we're changing the direction index, but we're not actually changing the direction. So we could do something like then say this dot direction is assign the value of directions at this dot direction index. Okay, we could do something like that. And let's see. Are we? Well, okay. Here, let's start actually working with this stuff. So we'll say const student lineup. Should I capitalize the U there? Does that make sense? Did they do it up here? No, they didn't. Okay, so let's be consistent. Line up. Good. Student lineup is assign the value of new line. And we'll give it 4 guys, just like in the example over here. And what are we going to do with that? Well, basically we want to keep track of the number of times they're all facing the same direction. We'll call that total, and that'll ultimately be the thing that we want to return at the end there. So I guess what we can do for now is we can say for command of commands, nice little for of loop there. So keep in mind that's equivalent to doing something like for let I be assigned the value of 0, I is less than commands.length, I plus plus, const command is assigned the value of commands at I, which is a lot more complicated, so this is nice. All right, and what we want to say is total plus equals, okay. Maybe we don't want to jump to that quite yet. We'll say if student lineup dot, what do we call it? Shout command. Okay, because keep in mind, that's returning a true or false. So if it's true, we'll say total plus plus. We've got another one of these things where they're facing all the same direction. Let's try running that. Let's see if it's working, if it's going to pass the test. It doesn't look like it in this, or at least not for all of them. It passes some of them. Let's see what was wrong here. It's saying there are 5 times where they're facing the same direction. Well, it doesn't look like it. There's 1, 2, 3 times, so it's kind of disregarding these. Why would that be? Well, it's because none of these guys are doing the wrong thing. Oh, and I guess we don't really need all of this anymore, so we can make a little more space. none of these guys are doing the wrong thing. None of them are facing the wrong direction. Yeah, how do we create the bad one? Well, let's find out. Let's investigate. In fact, you know what? That thing I just deleted is actually going to be kind of useful for this part. So, okay. Yeah, what do we want to do next? I guess, yeah, we want to have some wrong students. That would be a good thing. But, before we get into that, I sort of want to sort of keep track of some of these students. So, okay, yeah, there are a couple of modifications I want to make. Before we get any deeper, I feel like, I'm starting to get a bit attached to these students here. Like, I'm developing a bit of a fondness for them. So I think at this point, it's getting awkward that we don't know each other's names. So let's give these guys some names, okay? So we'll do this.name. And it's going to be a string. Something. We don't want them all having the same name, right? So we actually want to have maybe something that's going to generate names. So let's make a function that's going to generate some names here. What should we call it? Get name? Get name. Okay. And how could we do this? I want there to be some randomness in here, but I don't necessarily want it to be like totally random. Like I don't want it just being a string of random characters. But at the same time, like I don't want to have to go look up a database of names or something like that, or grab like a big array of names. So what we'll do is we'll make something kind of clever. Okay, so we're going to have two arrays here. So we'll say first parts will be one array, and then last parts will be another array. Wow, I did that capital A thing twice. Whew. Okay, so here we go. Basically, the idea is that we want to return some random first part and some random last part. And just to give you an idea of what I mean, like, if the first part's Tom, maybe the last part is son, or maybe it's Kins, or Kinson. Okay, so it could be Thompson, could be Tompkins, it could be Tomkinson. Or let's get some other ones. So we've got Tom, I guess we'll put Jerry in there as well. Maybe another Tom, like Thom sort of thing. Maybe Thor as well, that'd be a good name. Will, Wilkinson, something like that. Jeffer. Craig. Oh, should we get Bob in there? Okay, Bob and Hulk. And then let's get a few other last names or last parts, I guess. So we'll say Smith, Barry, and just Y. Okay, cool. Now, should I risk making that bigger? Oof, okay, it's getting a bit wide, but that's fine. All right, so basically I'm going to do something like this. So I'm going to do a function called rand. Okay, and what rand is going to do is it's going to take in some array. You may be able to guess which array or arrays we're going to be putting in here. And what we're going to do is we're going to return a random element of the array. Okay, so how do we get a random element? Well, Math.random, we don't get a chance to really use this very often in these code fights things because we're not trying to generate random content or anything like that most of the time. This is one exception. And you might argue it's overkill to give these guys names, but hey, like I said, I'm getting attached. So, okay, Math.random, and basically we want to multiply that by the array length. The reason we want to do that is because by default, Math.random is going to create a random floating point number between 0 and 1. I think it could be 0 but could not be 1. That's my understanding of it. Anyway, so we want to multiply this by array.length. And then we don't want like a double. We don't want a floating point value. So we'll take a floor of all this stuff over here. All right, cool. And basically what we want to return with this name thing is we'll say rand first parts concatenated with rand last parts. Okay, and then let's see if that's working. So return get name. Okay, we'll just get a name. Craigkinson. Oh, what a nice name. Are they all different? Yeah, Jerry Smith, Greggy, Tom Smith, Jeffer Smith. Lots of Smiths. Bob Barry, that's a good one. Craig Barry, Jerrykins. Okay, so I think this is working good. We're getting a random value from each of these things. It's concatenating them together. Now, one thing I just want to mention, and it's up to you. I mean, this is, you might consider this a bit hacky, but just because we've been talking about a lot of bitwise operators and stuff like that, you remember these, the numbers we get from bitwise operators, it's always like a binary number, right? Which we then represent as a decimal number, but the point is, it's always an integer. It's a 32-bit integer. So if we want this to be an integer, we were doing Math.floor a minute ago, but we could also just do a 0 or, because then it's essentially going to typecast this to a 32-bit integer. And so it's still going to work if we do it this way, Tompkinson. Because, you know, it's the same as floor. It's basically just saying, oh, well, all that stuff that comes after the decimal point, I'm just going to ignore that. I'm going to truncate that right off. Well, that's what floor is, right? Rounding down. Even if you've got a 0.9 at the end, you round down. So that's basically another way of doing that. Just a funky little trick here. It's up to you. I know in terms of reader clarity, it's probably not the best. So if you prefer to do like Math.floor, totally fine. Anyway, we've got our getName function over here. So maybe let's go down here and instead of something, we'll say getName. And specifically, this is really important, okay? So we're invoking the function getName. We're not saying that this.name is assigned the value of the function getName. It's the result of getName. Okay, so it's really important. We're not saying this.name is a function. We're saying it's the result of when we call this function up here. Okay, we're getting a lot of stuff in here. What do we want to do next? We want some of these guys to be wrong. So let's do that. Let's make some of these guys wrong. Okay, so how are we going to do that? Well, basically, first of all, let's make an attribute, this.wrong. And we could say it's false, or we could say it's true. It'll be a boolean. Let's actually say, let's make that, well, actually, hold on a sec. We have two options. We could handle it here in the student object, or we could basically handle it over here in the line object. I'm thinking we should use the line object for a reason. That's going to become clear hopefully pretty soon. But basically, we'll use wrong as the argument for each student, and we'll just assign that over here. So this.wrong is whatever that is, okay? Maybe I should have like a different name for that, because you know it might be that they're right if wrong is false, but anyway, this is probably fine. Now, basically, turn factor. This is the thing that's going to get affected by wrong here. Okay, so turn factor. I guess what I'll say is something like this. So if this.wrong, then turn factor is going to be assigned the value of 3 minus turn factor. Does that make sense? Let's see. Ooh, no, that doesn't make sense. Okay, wait. Would it be 4 minus turn factor? I'm just trying to think here. So, okay. Yeah, actually 4 minus turn factor. I think that makes more sense, because the turn factor, if it's left, it would be 1, right? So 4 minus 1 would be 3, which would be the right turn factor. Okay, and then likewise, 4 minus 3 would be 1. So, okay, we're getting those mixed up. And also 4 minus 2 would still be 2, so it wouldn't affect the A version of this, okay? So if this.wrong, turn factor is going to be 4 minus turn factor. So it's basically going to be the opposite of what it normally would be. Okay, so how should we handle this thing? So maybe for this part over here, I mean, I'm using a this.every, but maybe it would be neat to actually see sort of like a little console log of how they're actually all facing. So let's do a console log, and I'll do a map. So this.students.map. So for every student, what are we going to see? What we want to see is their name, student.name, and we also want to know what direction they're facing. So we'll say, we'll put this in an array, and we'll say student.name and student dot direction. Okay, so we'll console log that. And we've made a lot of changes here, so I don't know if this is actually going to run. We'll probably get some kind of error, but let's find out, I guess. Okay, so that's still saying 5 instead of 3. So what do we have here? This should give us, yeah, we're getting like every step of the way here. Okay, so what happened? So after the first command, they're all facing left. After the next one, they're all facing backwards. So we've got 4 students here. We've got Tompkins, Hulkberry, Tom Smith, and Tom Berry. Oh, it's like those Final Fantasy guys with the knives. Anyway, okay, so they're all facing left after the first command. They're all facing backward after the next command. They're all facing forward after the next command. So they're all sort of matching up every time, which we don't really want. We want some of them to be wrong. But here's the thing. We're saying, yeah, we want to assign them whatever value we're getting here for wrong, but we're not actually doing that at any point. So we need to make some of them wrong. So on what basis are they going to be wrong? Well, basically, we could do something like this. Const wrong is assign the value of, and then we'll just say Math.random is greater than 0.5. So this should be like a 50-50 chance here, right? So if Math.random is greater than 0.5, then we'll say it's true. Otherwise, we'll say it's false. Now, wait a sec. Hold on a second here. Look at what we're doing. We're saying if this thing is true, yeah, give us true. If this thing is false, give us false. Well, no. I mean, basically what we want to say is if this thing's true, it's already true. If it's false, it's already false. So we can just use this as a boolean. So, and then we'll put that in, and this should give us some random number of students who are going to be wrong. And yeah, it's when we create the students. So let's run this, and oh, okay. So they're all facing the same direction again. Is that just by chance, or are we doing something wrong over here? So yeah, it feels like some of these guys should be wrong. Wiley, that's a good name. Let's run it again, just, in case it was just a fluke. Okay, so we're not getting wrong. Let me try this for a sec here. Console log wrong. Let's just make sure these are all like that okay, so we're getting false for every one of these. Oh, I'm not actually calling Math.random. There we go. So hopefully that'll work. Assignment to constant variable, where? Line 27. Oh, yeah, that shouldn't be constant. That should be a let. Okay, thanks. Thanks, console. Appreciate it. Oh, okay. I accidentally tried to submit there, but okay, great. So we're passing the sample test, and let's see what's going on. So, okay, in this case, 2 of them are wrong, 2 of them are not wrong, and that's pretty much perfect in a lot of ways. Okay, so in this case we have Jerryson, Jerrykinson, Hulkson, and Wiley, and we find that Jerrykinson and Wiley, they're wrong. And so they're facing the wrong directions after this left turn. They ended up right, but then everyone ends up facing backwards. We're all reoriented at that point, and then we turn around. We're all still facing the same direction, but then they throw a right turn at us, and again, Jerrykinson and Wiley, not in the right direction, and then finally back to the left, they end up all in the same spot again. Okay, cool. Well, that's quite a tale. So let's just run the tests again. I'm curious about something here because I see a potential flaw in our algorithm, but I don't know how likely it is to happen. So maybe just to make it more likely to get this this bug happening, I'm gonna shorten the line up for a sec here. So, oh really? Oh, it's still mad at me. Okay, sorry. We'll just take a minute. We'll let that cool down. Make sure it forgets about us, forgives us. In the meantime, hopefully everyone's having a great day. Anyone have any questions about any of the stuff we've done here so far? Oh, well, actually, okay, there's another thing we could talk about, and it has to do with these directions. So, okay, well, let's see if we can run it yet. Great. This is what I was looking for. So notice we're now only passing half of the tests, and it's because, check this out. So we've got Wilkinson and Thompson, and we find that both of them are they're both wrong, I guess, right? They both had a true for wrong. So basically in this case, since they're both wrong, like remember it said in the specifications over here that, where was it? It said somewhere that it's some of them are wrong, but not all of them. Yeah, some of the students, not all of them, but at least one. This is a really important line here because we're not abiding by that right now. They're all wrong in this case, so the not all of them is being violated. So because of that, let's do something a little bit different. So specifically at this point in here, and here's the other thing, like the lineup needs to have at least 2 kids in it, right? At least 2 students. It has to be, because otherwise there wouldn't be a possible way of having not all of them wrong, but at least one of them, right? So there has to be at least 2 of them. So with that in mind, I'm just going to load up 2 students to begin with. Okay, so instead, actually, I don't even need an extra line for that. I'll just do it right here. So we've got this.students, and I just want to preload 2 of those things. So I'm going to say new student who is wrong, and then a new student who is not wrong. Okay, we'll just get one of each of those in there right off the bat, and then I guess I'll do length minus equals 2 just so that's the proper length. And now when I run this, oh god, okay, I didn't mean to submit. Okay, sorry about that. I meant to hit a control R, but I got a control enter. Oh, hey, thanks. Anyway, let's go back to this for a sec. So let's run this. Let's get the guys back in the picture. Okay, so here, wait, they were both named Tompkinson? Hey, that's not cool. So there was one of the Tompkinsons was right, the other one was wrong. Oh, Jefferkins and Bobbery. Okay, so again, they're facing in opposite directions. One of them's right, one of them's wrong. Oh, nobody there. Okay. Jerry Berry, that's... Okay, so Jerry Berry was the wrong one this time. Okay, so great. And keep in mind, like, we could make this really long. We could make it like a pretty significant lineup here. Yeah, okay, bunch of false and truths. So we got Jeffrey. I didn't even consider that one. Jeffrey, Tom Berry, Jefferkins, Jerry Smith, Wiley, Bobby, Tom Berry, Tommy, Wilkins, and Jefferkins. And we're finding that some of them are turning in the right direction, some of them are not. Okay, cool. So this is great. This is working. It's, hey, it got us the win, right? We've got a few too many console logs here. I actually do like this console log because it sort of shows us what's going on with all these guys. Nice little check-in. What's a good lineup size? Maybe 4 was ideal because it kind of reflects the problem here. But hey, there's one more thing I want to say about this before we move on to a different strategy. And it's this. We're basically taking our direction index, right? We've got a direction. Hey, we don't need that anymore, actually. We don't have like a global direction index. Okay, so we've got our legend. We are using the legend. And there's another way we can do that. We'll look at it in just a sec. We are using directions as well, because we're basically looking that up. We're taking our direction index, we're looking it up, and using that to find what the direction is. But the thing is, like, we're comparing the directions. We're basically saying, hey, is this R and this is also R? Oh, it's not? Oh, okay. Well, then they're not all facing the same direction. What difference does it make whether it says R or whether it says 3? You know, if this is 3 and this is 1, isn't that the same thing? So could we just get rid of directions altogether? Could we not have a direction for our students here, not worry about the direction over here, and then when it comes time to actually checking them, instead of doing this dot direction, we could do like a direction index? Maybe that would work. I mean, I don't see why not, right? The only difference is now when we actually go to run this thing, what we're going to find is that instead of lefts and rights, we're getting numbers, which is fine. We don't need the letters in this case. It's just like an extra step. So it's up to you. If you prefer it, you know, with the words and stuff like that, well, yeah, that's fine if you prefer that. We do need to keep the letters in here because like these are the commands. And so this is basically giving us the numerical version of each of our commands here. Okay, now what's that other thing I said we can change? Well, actually, yeah, it's this. So my claim is another way we could do this legend thing is to say, actually, how are we doing it? So we're saying legend at command. Okay, so instead we could do something more like this, where we say the legend is space LAR. You might be looking at that and thinking, what? Hey, what are you talking about? And yeah, it seems a little strange. And I'm not just going to say legend at command. Instead, I'm going to say legend.index of command. In fact, well, okay, let's see if that runs first of all. No, it doesn't because it's a constant. You can't reassign it. Let's try it this way. Yeah, it runs. It's fine. No problem. Okay, so it seems a little strange to have this as just like its own object. I'm just going to put it in here. It's actually shorter than or I guess the same length as the variable name we were using. So it's just space lar.index of command. How's that working? Well, basically, if command is, let's say, A, then it's going to say, oh, where's the A here? Oh, it's the character with index 2. Great. L has index 1. R has index 3. Sorry, it took me a sec there. And those are the values we want. That's what we had in our legend just a second ago. Why do we have the space here? Well, without it, we would have to basically add 1 to the end of this thing, which probably just more efficient to put in the space. It's fewer characters, so yeah, okay. I think that's good. I think that's working. Is there anything else we wanted to change here? Let's see. Yeah, that console log can stay. This is basically just loading up all the students over here. This is the one method that we need, basically just shouting out all of the commands, and then we're getting this return statement, which tells us if they're facing in the right direction or the correct direction. And then basically the only other concern here is, like, are we going to have another situation where we don't have like a sample size big enough? Like, are we going to have another situation where there aren't enough students where like either they're all wrong or they're all correct, all not wrong? Are we going to have a situation like that? And the answer is no, because we're guaranteeing right off the bat that there's at least one wrong student and one not wrong student. So this should always pass all of the tests, no problem. Great. Okay, so that's nice. Feels good. I think that's kind of a funny way of doing this problem. It's I mean, I like seeing all their names. That's a lot of fun. But yeah, it is overkill. It's huge overkill. I mean, this is over 50 lines. This does not need to be over 50 lines. So, okay, let me try to do something slick here. I'm going to put a 1 there so that it doesn't run properly. We should get a null. And I'm going to control X this, and then I'm going to reset the code, confirm that, and I'm going to paste this in down below. Nice. Okay, so now we're going to reattempt this. Let's go back to the drawing board, so to speak. Ugh, I don't like the way that's bleeding onto the next line, so let's just get that out of our sight. Okay, cool. So now if we run this, it should give us a different, not an error. It should just tell us that we're getting nulls for everything. Great. That's what we want. Okay, so check it out. Here's the thing. When we're looking at this problem, we can ask ourselves, under what situation, under what circumstances are they not going to be facing in the same directions? Under what circumstances will they not be aligned? Okay, so we start out and basically these guys are all facing the same direction. We want to know how many times are they going to be facing the same direction, and that's the thing that we're ultimately going to be returning, which I think is consistent with what we had. Oh, we called it total before. Okay, I guess we're calling it times now. How many times did it happen? Anyway, okay, so what do we want to be doing with this? Well, basically, we want to check when they're going to be aligned, when they're not going to be aligned. So the idea is that if they were already aligned and we get a left or a right, then they will be not aligned. If they're already aligned, like over here, and we get an A, then they're still aligned. And if they were not aligned and we get a left or a right, then they will become aligned. If they are not aligned and we get an A, and unfortunately we don't have an example here, but it would look something like going from from this one here directly to this one over here. That's basically the idea. So they're all switching directions. They're all doing a 180, but they're still not facing the same direction at the end of that. They're not aligned. Okay, so how do we want to deal with this one? Well, basically, we'll just go through the list of commands here. We'll say for const command of commands. And the way we want to do this is we'll say, okay, if command is A, then we're going to do one set of things. And otherwise, we'll do some other set of things. So if it's not A, then we're going to switch the alignment, right? If we're turning left or right, then again, if they were aligned, they become unaligned. If they were unaligned, they become aligned. So a quick way of doing that would be to say aligned is assign the value of not aligned. Okay, it's just the opposite of what it was before. I'm wondering if it's possible. No, it's not. I was going to say, I wonder if it's possible to just do like a not equals, but then I realized that means something a bit different. So, okay, aligned is assign the value of not aligned. And if the command is A, then I guess we don't need to do anything. You know, like if the command is A, then we're keeping it the same. So if they were aligned, they'll continue to be aligned. If they weren't aligned, they'll continue to not be aligned. So really, I guess the better way of doing this would be to say command not equals A. We could say like if command is L or if command is R, but it's probably easier to just say command not equals A. Then aligned is not aligned. And then at the end of this, after we've switched them in whatever way we need to, we'll say, well, if aligned times plus plus, kind of like what we had at the bottom over here, right? Yeah, if they're all lined up, total plus plus, same sort of thing, times plus plus. Let's see if that runs. We'll see if it gives us what we want. After this moment of suspense. Yeah, okay, cool. It's passing all the sample tests. So, okay, this is a debatable point. Let me know if you have a different opinion on this, but I'm thinking this method here, this strategy, this algorithm up top, is a little simpler than this one down here. I don't know, it's debatable. Anyway, the point is, so for this one, well, actually, we can simplify this even further. We can just put this up here, run that, and yeah, that works. But hey, there's another little trick we can do here. So aligned is basically a true or a false value, right? If we tried to do some math with a true or false value, I wonder how that would be typecast. So basically, could we do something like this, like return 5 plus false? Does that even make sense? We'll see if it gives us anything for that. It's just 5. Okay, so maybe it didn't do anything. I'll try 5 plus true. Oh, it's 6. So yeah, basically it's typecasting true to 0. True to 1 and false to 0. That's the idea. Well, that's very convenient for our current situation here because if aligned, times plus plus. If not aligned, not times plus plus. In other words, times plus equals aligned. That's it. That's really all we need to say about that, I think. Let's verify that. Yeah, that's all we need to say about that. In fact, we technically even don't really need to be doing any typecasting here. We could say that this is 1, and instead of doing not aligned, we could do 1 minus aligned. And then that's, a little simpler that way, I would say. Yeah, that's probably a little simpler, a little more mathy, I think. Okay. Yeah, I think that's about it. Here, there's one more thing we can do here. It's a bit strange. I don't know. You might not like this. Maybe you will, but let's think about how we would do this if we were like trying to do code golfing or something like that. Maybe not even, but if we were just trying to sort of simplify this and we wanted this to be like a little bit tighter here. Well, okay, so how do I put this? This is kind of like an XOR here, right? Like command is not equal to this. And essentially what we want to do is we want to know if, okay, so hold on, let me back up a sec here. So what we had a minute ago was this, right? So if command is not equal to A, then aligned is not aligned, okay? So another way we could do this is we could just assign it. We could say something like aligned is assign the value of, we'll use like a boolean, a ternary, I guess. It's too many equals. Command is not A. And then it's going to be not itself. or itself. But I think, isn't this kind of like an XOR situation? Let's see. So we've got aligned, we've got command is not equal to A, and then this becomes not aligned or aligned. Yeah, so basically, okay, because this is true or false, right? So aligned is true or false right now. This is also going to be a true or false thing. And we're saying that if this thing is true, then this one becomes false. If this thing is false, then this one becomes true. Maybe I should flip this around. I don't know if that would make it maybe a little more clear. Put the not over here. But basically it feels like we're kind of taking on like the false value of this thing over here. So yeah, I realize it's getting a bit messy over here. I'll fix that stuff up in just a sec. But before I do, so we've got aligned is assigned the value of command equals A. And then if so, if it is A, we'll say, yeah, whatever it was. If not, whatever it wasn't. So it's basically, if this is true, then this is going to be continuing to be the same thing. If it's false, then we're going to flip whatever this was. So yeah, I feel like there's an XOR situation here, right? Couldn't we sort of do something like that? Let's see. Okay, so I guess I'll just use A and C to sort of represent these things. So A would represent aligned, either they're aligned or they're not. And then C would represent that the command is an A command. Okay, and we'll get something coming out of this. And what we want, I guess, is, okay, so if they are not aligned and the command is not an A, then they'll become aligned. If they are, if they're not aligned and the command is A, then they're going to continue to be not aligned. If they are aligned and the command isn't A, then they're going to become unaligned. And if they are aligned and the command is A, then they're going to continue to be aligned. Okay, so actually this is kind of the opposite of what we're looking for, right? Because this is sort of like a not XOR, I think, right? XOR would be 0, 1, 1, 0. So, okay, a way of doing XOR would be something like this. There, okay. Right? Or more like this, I think. So, oh geez, I shouldn't have erased what we had before. And then we want if aligned times plus plus. So, did we mess this up or is this right? No, we messed it up. So basically, the idea here is that it's not that they're not equal. I think it's that they should be equal. Is that how we mess it up? Yeah. Okay, so basically that's getting a bit complicated, but this Boolean statement here, the fact that the command is A, if that is the same as the current alignment, if it's true, then this is going to end up being true. Otherwise, it's going to end up being false. Okay, and then aligned, well, we're assigning it up here, right? So we could really just take this, get rid of the semicolon, and just replace this with that assignment. So now it's all kind of happening like on one line here. In fact, since this is just one line, we could even do something like this. And it's getting kind of ugly, but there. Maybe that's okay. I don't know if that's actually 80 characters. Who knows? But it's passing the test. Seems to be working. So yeah, that's pretty not bad, I guess. We'll just submit that one. And actually, hold on. Let's reduce some of the spacing in here. Yeah, and let's do a final submit on that one. So, I mean, these two are kind of nice. Like, they're a lot shorter. They kind of get right to the point, I guess. But I don't know any of the students' names using these strategies. So I guess I have a bit of a soft spot for this one down here. All right, well, I think that's it for that one. So nice job, everyone.